Hello friends, welcome to the session on data structure. In this session, we'll be discussing one operation on the tree, and this operation is being called as a traversing operation. Friends, as you know that tree data structure is very frequently used in many algorithms in computer science. You will find that whenever we have some real life data, some kind of hierarchical data, then that kind of data can be represented in memory by using the tree data structure. The tree data structure is not only used to represent the hierarchical data, but you will find that in many other algorithms. Say for example, whenever we write the algorithm of searching and sorting, or whenever we write the algorithms in compiler design, there you will find that we need this data structure that is being called as a tree. And in the tree, the most commonly used operation is the traversing operation. So in this session, we will understand what we mean by traversing of a tree and what are the different methods that are available in order to traverse a tree. Friends, as you know that you are viewing this session on the YouTube channel of PSSCIVE, and you will find that these sessions are being recorded for the course Junior Software Developer. But the students from other courses also can make an access to these sessions in order to learn the topic of data structure. So let us start the session and understand what we mean by traversing of a tree. Suppose we have been given a tree as shown in this diagram. Suppose we have been given a tree, and in the tree we know that there is one root and then there are childs of the roots. The child 7 can be called as a parent, and you will find that 2 and 6 can be the childs of the parent 7. Similarly, we can have the parents and their childs. So this is a structure which can be called as a tree data structure. And whenever we want to visit each and every element of the tree, then visiting or processing of each and every element of the binary tree, that is being called as a traversing operation. So like we have seen traversing operation in arrays or traversing operation in queue, where you will find that we visit each and every element of that data structure. In the same way, in the tree also, you will find that we can visit or we can make an access to each and every element of the tree, and that is to be called as a traversing operation. So there are different ways to perform the traversing operation in tree. The first way is being called as a pre-order, the second way is being called as a post-order, and the third way is being called as a in-order. So there are three ways to perform the traversing operation, and we will check what is the algorithm in order to perform all these three different types of traversing operation. Now the first operation that we will be discussing is a pre-order traversing operation. So in the pre-order traversing operation, we perform it like this: N, L and R, where N will stand for the node, then L will stand for the left subtree, and then the R will stand for the right subtree. So pre-order, as a student you have to remember this sequence of N, L and R. So N means the root or the root node, you can say, then L, that will stand for the left subtree, and then you have to visit the right subtree. So the steps of this algorithm are like this. First of all, you will visit or you will process the root R, and then you will traverse the left subtree of the root R, and then you will traverse the right subtree of the root R. So whenever you are making the pre-order traversing, then in the pre-order traversing, visit the root, then make the access to the left subtree of R, and then make an access to the right subtree of R. So this is the way you can make an access to the elements of the tree. Say for example, here we have been given some figure, and this is a tree data structure. Now as far as this order is concerned, which we call as a pre-order, in which initially we will visit the root, therefore our first element of visit will be 1, then we will come down to the left subtree where we will visit the node 2, then we will visit the node 4. Now the left part is being over, and therefore now from 4 we will go to the part or to the node 3, which is on the right hand side of root R. and then we will visit the left side of it. Therefore, we will visit 5, then we will visit 7. Now, the left part is over, and therefore, now we will move to the right part. Therefore, we will visit 8, and then finally we will visit 6. So, this is the sequence. This is the sequence where we can visit each and every node of the tree. So, the sequence in the pre-order is 1, 2, 4, 3, 5, 7, 8 and 6. So, the pre-order sequence will be like this. Let us take another example. Suppose we have been given a tree like this where A is the node, B and C are the childs of the root A, and then B is having the child D and E, and C is having the child F. Now, in the pre-order traversal, what we will do, we will visit the root first, and then we will visit the left subtree. Therefore, we will visit the B, and then we will visit the element D. So, we will visit A, then B and then D. After completion of that, we will go to the right subtree, and there we will visit the E, and then we will visit the C, and then we will visit the F. So, you will find that our sequence of access will be like this: A, then B, then D, then E, then C and then F. So, this is the way you can make an access to the elements of the tree, and this order of visiting or accessing the elements of the tree is being called as a pre-order accessing. Let us consider another way of making an access. As I said, there are 3 ways by which you can make an access to the elements of the tree, and this second is being called as a in order access. Now, in the in order, the sequence is like this: L, N and R. So, L means the left subtree, N means the root R, and R means the right subtree. So, initially you will traverse the left subtree of R in order, then you will process the root R, and then you will traverse the right subtree of R in order. Now, as far as this particular figure of the tree is concerned, you will find that we will start from the left subtree. Therefore, we will start from the 4 here, then we will visit 2, and then we will visit 1, that is the root, and then we will visit to the 7, then we will visit to the 5, and then we will visit to the 8, and then we will visit to the 3, and then finally we will make an access to 6. So, remember the sequence in what way we are making an access to the elements of the tree. So, this is L, N and R. So, first of all you have to visit the left subtree, then the root, and then you have to visit the right subtree. Let us consider another example. Suppose we have been given a binary tree where A is there, then B and C are the child, and then D, E, F is there. Now, what we will do is that first of all we will visit the D. So, we will start from the left subtree, then we will visit its parent B, then we will visit E, and then we will visit the parent A, and then we will visit C, and then we will visit F. So, this is a sequence of operation that we need to do whenever we have been given a certain tree, and this order of making an access to the elements of the tree is being called as an in order access. The third access is being called as a post order access, and in the post order access you will find that the sequence that we follow is L, R and N. So, first of all we will visit the left subtree of a tree, then we will visit the right subtree of a tree, and then finally we will visit the root. So, we will traverse the left subtree of R in the post order, then we will traverse the right subtree of R in a post order, and then finally we will process the root R. Say for example, if you have been given certain diagram as shown in this window, then here we will visit first of all 4, the element from the left subtree, then we will visit 2, then we will visit the 7, then we will visit this element 8, then we will visit this element 5, then we will visit the element 6, then we will visit the element 3, and then finally we will visit our root 1. So, the sequence of visiting or making an access to the elements will be 4, 2, 7, 8, 5, 6, 3 and 1. So, this will be the sequence of making an access to the elements of the tree. So one can easily find that whenever we want to implement these algorithms, then these algorithms can be implemented by making the use of the stack. So you can make the use of the stack memory for the implementation of them. And of course, one can easily observe that within an algorithm, we are calling the same procedure or same function again, and therefore these algorithms can be recursively defined. So this is another example of the post order. Suppose we have been given the root A, B and C are the childs, and then further we have the leaves D, E, F. Now here, as per this post order, we will visit B first, then we will visit D, then we will visit E, then we will visit C, and then we will visit F, and then finally we will visit the A. So we will have the sequence of auction or visit like this: D, E, then B, F, C, and then finally we will visit the root A. So that will be the sequence of actions that is being followed in the post order traversal of a tree. So these are the three methods. One can use any method as per the requirement, but all these three methods ensure that all the nodes of the given tree are visited or access to every element is being there. So thank you friends for viewing the session. Hopefully you have understood how to traverse a given tree by making the use of three different methods. Thank you all for viewing.